In this lecture, we are going to discuss some of the key security protocols used in networks. This is an interesting figure because it tells you where each of these protocols reside in the protocol stack. So for example, we have HTTPS and SSH which reside at the application layer. Then we have SSL and TLS which reside at the transport layer. And we have IPSec which resides at the network layer. From a conceptual perspective, it is very important to be aware of where each of these security solutions reside in the protocol stack. Let's start with the HTTPS protocol. So HTTP stands for Hypertext Transfer Protocol, one of the most widely used protocols on the internet because this is the protocol which is used for web browsing. So the problem with the HTTP protocol is that it transmits data in plain text, which means that if you send your credentials over HTTP, so basically if you're sending your login details, passwords, or your banking information, anybody who eavesdrops on this traffic will be able to extract this information. Hence, using HTTP is not a good idea. You should always strive to use HTTPS, which basically encrypts your data as it traverses the public internet. So let's say if you're using the traditional HTTP protocol and you're sending your username and password, then it will be transmitted in plain text, and anybody who eavesdrops on it will be going to access your information. In contrast, when you use the HTTPS protocol, what it does is that it encrypts your data so that even if somebody eavesdrops on it and they get a copy of your traffic or your packets, they will not be able to break it easily because HTTP uses some state-of-the-art encryption algorithms which are very hard to break. So as a cybersecurity professional, you should always strive to use HTTPS in your organization and when you're designing cybersecurity solutions. So if you visit a website and you see this small lock icon, then it means that this website is using HTTPS. So let's discuss SSL and TLS. So SSL stands for Secure Sockets Layer. It resides at the transport layer of the protocol stack and it protects communication by encrypting it. So remember when we discussed HTTPS? So HTTPS is basically the good old HTTP, which just uses the encryption mechanism of SSL or TLS at the transport layer, and hence the name HTTPS. So basically, you should remember that SSL is basically deprecated now. It was shown to be vulnerable to certain types of attacks. So that's why we now only use the TLS, which is transport layer security. TLS always uses port 443. Now, basically what this means is that a client is going to connect on the server on the port 443. So which basically means HTTPS is using 443 because HTTPS uses TLS. Now this is in contrast to the HTTP protocol which basically used port 80. So you should always be using port 443 and HTTPS/TLS whenever you want to communicate. What happens is that when a client wants to communicate with the server or using HTTPS, then it connects on port 443 and the server responds with its digital certificate. And what is a digital certificate? It basically contains the public key of the server so that the client and the server, they can both encrypt and decrypt. Also, the client and the server, they need to agree on the encryption scheme. So basically, a server can handle some type of encryption schemes and the client has its own stack of encryption schemes that it can handle, and they need to negotiate and decide on a mutually agreeable encryption scheme that they can use. Let's discuss IPSec. IPSec stands for IP security, but before we delve into the details of IPSec, let's first contrast it with HTTPS and TLS. So basically, as we discussed, HTTP resides on the application layer, but HTTP uses TLS to offer the HTTPS flavor. And since TLS resides at the transport layer, so that's why we call it as a transport layer solution. So what happens is that because initially when the client and server, they start communicating, they don't have a common shared private key. So what they do is that they use public key cryptography to create this encrypted tunnel. But once this tunnel is created, they use this secure tunnel for exchanging session keys or private keys. Now there's a reason why private keys are used. You see, public key cryptography is slow. However, private key cryptography are quite fast. So when you want to do the actual encryption of data, you want to do it quickly and efficiently. So for that, you need to use session keys or private keys. It should also be noted, in order to enhance the security, these private or session keys are periodically rotated. So every few seconds, new keys would be generated and exchanged between the client and server securely within this tunnel, which was created using public keys. In contrast to this, the IPSec protocol works at the network layer. So it encrypts at the network layer, and it can also use both public and private keys. As we discussed, IPSec is a network layer solution, which basically means that it encrypts at the network layer, and it encrypts regardless of the upper layers. So basically what happens is that even if you're encrypting data using HTTPS/TLS, but you're using IPSec, it's going to encrypt that whole thing once again. So basically it works independently of the upper layers, and it operates at the network layer. IPSec is very popular for creating tunnels, and one of the biggest uses for IPSec is in VPNs, or virtual private networks. Now, IPSec provides CIA, confidentiality, integrity, and availability. Let's have a look at virtual private networks, a very important concept in cybersecurity. So the basic idea of VPNs is that they extend a private network over public networks. So what this means is that, let's say you work in a company and they have a very secure corporate network, and now one of the users wants to access this network from his home. He's working remotely perhaps. You cannot add exceptions to your firewalls and other security tools, because this is going to make your network vulnerable. So what you do is that you use a VPN to create a secure and encrypted tunnel from that user's system to your corporate network. And that user is going to access your corporate network through that secure tunnel. Now this makes communication secure and overall your network secure. Now basically, so what happens is that, let's say you are a user here and you want to communicate with your corporate network. What you're going to do is that you're going to create a tunnel to the gateway node of your corporate network. And this tunnel would be created using IPSec. And so basically any communication which happens within this tunnel would be very secure, and you'll be able to access services of your corporate network securely. Now, IPSec offers two modes of operation: transport mode, in which we encapsulate only the data or the payload, and this is used for device-to-device communication. We also have the tunnel mode, in which the entire packet is encrypted, which means that not only you encrypt the data, but the headers as well. And this is mostly used for gateway-to-gateway communication. IPSec uses two different types of protocols. The first is authentication header, which focuses on authentication. And then we have the encapsulating security payload, which focuses on authentication as well as confidentiality. Let's contrast the transport and tunnel modes of IPSec. In the transport mode, we usually have host-to-host communication or app-to-app communication, and we encrypt only the data or the payload, not the header. Now, one advantage of not encrypting the IP header is that when routers on the internet, they need to route your packet, they can do so very easily because the IP header is not encrypted. So they can have a look at it and route your packet accordingly. In contrast to this, in the tunnel mode, when we encrypt the complete packet, it also encrypts the IP. So basically this means that the routers on the internet will not be able to route your packet. So how do we solve this problem? We add a new IP header, which basically contains the destination IP of the gateway of your corporate network. So basically this will be put, so your original packet will be enveloped with this IP header. And anybody looking at this packet, or the routers on the internet, when they look at this packet, they think it's going for the gateway. However, what really happens is that when this packet reaches the gateway is going to extract the internal packet and send it to the appropriate destination inside the corporate network. Now let's see both of these modes in operation. In the tunnel mode, we have a gateway-to-gateway secure tunnel. What we do is that so basically this is your data, and then you have the other headers such as the application header, transport header, and IP header. Remember, we discussed that your data is enveloped by different layers. They add their own headers and they kind of envelop the packet. So in the tunnel mode, we encrypt the entire packet, including the data as well as all the headers and especially the IP header. Now, after doing this, we add a protocol header such as AH or ESP, but we also add a new header. Now this new header would contain the IP address of this gateway. And we're doing this because the original IP header of the packet is encrypted now. So the routers on the internet, they cannot see the actual IP address. So you need to kind of, envelop this whole packet with a new IP header. So when you send this packet, when this packet arrives at this gateway, it's going to extract the internal packet and then route appropriately. In contrast, in the transport mode, we have host to host or app to app communication, and we encrypt only the data and the upper layer headers. We don't encrypt the actual IP header. So the actual IP header remains open and unencrypted, and this enables easy routing on the internet. Of course, there's a downside as well. So basically, when you're using tunnel mode, since the IP header is also encrypted, so there's no way for anyone, even if they eavesdrop on this packet, to even know, what is the actual destination, because all they're going to see is the gateway IP address. In the transport mode, you see the actual IP address of the destination, so you can infer some sort of traffic patterns. However, generally speaking, both modes are very secure and they have their own specific use cases. Now let's have a look at secure shell. So the concept of secure shell is to enable remote command execution on remote systems. Now SSH resides at the application layer of the protocol stack, and the basic idea is to allow a command prompt or shell, usually for a remote machine. So basically, let's say you're sitting on your system, but you want to run some commands on a server in your corporate network. So for doing that, SSH provides a perfect solution. It's a very nice solution because it uses encryption to secure the communication. Otherwise, if your communication is in plain text, then anybody who can eavesdrop on your traffic can access your credentials. It runs on port 22. One thing you should always remember is never to use telnet. This is a counterpart to SSH and provides all the functionalities similar to SSH, but the problem with telnet is that it allows plain text communication. It does not encrypt your data. So basically, any communication that you do on telnet can easily be eavesdropped on. And telnet works on port 23. Running SSH is pretty simple. You just go to your terminal and type SSH, and then you can specify your username and the destination, or you can also be prompted. That concludes our lecture. I'll see you in the next lecture.